Good day, trainees. Welcome here to another video of forces. In this video, we are going to concentrate on vertical and horizontal components of forces. Now, remember in the section of parallelogram of forces, we were given two forces and then we had to determine its resultant, which was the diagonal that is equal to the equilibrium. Now, imagine your two forces that were given to you are your horizontal and your vertical component, and your force that you had to determine that will replace those two components is the resultant. Now, determining the horizontal and the vertical component of a force is a reverse process of determining your resultant and the equilibrium. So in this case, we are going to take your resultant and then we are going to resolve it into your two components. In the first place, we're given our our components, and then we resolved it into a resultant that will replace them. Now, in this case, what we are going to do now in this section, we are given a resultant and we are going to resolve it in its horizontal and vertical component, and that will be considering that we are given a certain angle. Now, there are two methods of solving your vertical and horizontal components that you are going to do in your syllabus of level 1. The first method is graphical method, where we will draw. The second method is the analytical method, where we will calculate our components. Now, we are first going to start with the graphical method. We are going to do two examples, and I'll proceed and I will explain the analytical method, and then we will do two examples. So, here is your first example. It says, graphically determine the components of the forces shown in the diagrams below. These are your two diagrams. The A has a force of 60 Newton acting at an angle of 55 degrees, and then B has a resultant of a force of 53 Newtons acting at an angle of 40 Newtons. We are going to do this step by step, and when we are done, I hope you will know how to draw your forces. So, you need your ruler and your protractor. As usual, our drawing equipment. Remember, we are drawing to scale, and the scale that we are going to use here our solutions will come just below there, and the scale we are going to use the 10 newtons equals to 10 millimeter, or the 1:1. It is fine. Now, we are going to start by measuring our angle so that we are able to draw our 60 Newton. You can also start with a dotted line that will guide you. If you are drawing in your book already have a line, so you don't need to make a dotted line. So this is the dotted line that will guide me to draw. That is my dotted line. Now, I will choose a point where I will start. Let me say this is the point where I will measure the 55-degree angle from. See that? So my 55-degree angle will be there. You take your ruler, mine is a combination, and you mark off 60 newtons. So that is your 60 newton. You can indicate that with your arrow, that the direction is in. You can indicate your direction with an arrow. This is your 55 degrees angle. Sorry for that. So you have your line of 60 newton that was produced by the angle of 55. Now the next thing is, you can draw, because your two components are unknown, you can have draw your two lines and say my horizontal component will go that way. Just make sure that the line that you draw will surpass that point, and then you can draw, make sure your lines are straight. Then you can also as well draw your vertical component on this side, ensuring that it's a 90-degree line, and then it will just pass the top of your 60 newton line. We just want to pass that line, and there you have it. Now what you are going to do, you are going to take, please use a set square because it's accurate for making sure that your lines are 90 degrees. You take your set square, and then from the top of the line of 60 newton, you indicate with, you can draw a solid line or a dotted line, and then you also do the same on the other side. You join the top of that line to your horizontal component line. It means the size of your vertical component will start here, and you measure it up to there. Your horizontal component will start at that point, and then the size will stop there. You indicate here that this 60 newton, this is your horizontal component, and this is your vertical component, and then you can measure and say VC in this diagram and HC will be equal to, let's see, so my VC is 36 newton. Remember, the mass is in the range of plus minus 1. Your answers must be in that range. Remember, we are drawing, and every time we are drawing, we want to make sure our diagram is accurate to an answer of plus minus 1. Now we move on to the next one. The next one, let me just again indicate my dotted line, which will help me to measure my angle. So that is the point I'll start from. Then I will measure my angle of 14 newtons. There, that will be 40 newtons. Then my force is 53. Let me just use this rule. 53 will be here, right there. That's where my line will stop. Okay, that is 53 Newton. You repeat the process. You draw your line that will indicate your horizontal component, and then up you draw the one for your vertical component. Then you join the top of your given force, making sure that the angle is 90 degrees. Then you also join the bottom, your horizontal component, to the top of the given force. Then you indicate that this is my vertical component and that is my horizontal component. This is by 53 newtons and this is 40 degrees. It's very, very important that you label your diagrams. Do not leave your diagrams without labels. Make sure they are labeled. Now you have got that. All you are left with is to measure your answers, VC and then AC. So in this diagram, my VC is exactly 35 newtons. My horizontal component of my AC is 40 newtons. And again we come to the accuracy or the range of plus minus 1. So this is how you do your diagrams, or remember these are vector diagrams and they are to scale. So this is how you construct them to determine your VC and your AC. We are moving on to the analytical method. Okay, let's continue. Now the analytical method. For the analytical method, we are using trigonometry to solve for our components. Remember, in trigonometry we have a right angle triangle and then we have a given angle in the certain triangle. We have three sides: the opposite, the hypotenuse, and then the adjacent. And remember, the hypotenuse is always the longest side in the triangle. Now remember our three ratios for trigonometry, our three trigonometrical ratios. We have sin, we have cos, and we have tan. Now if we are to relate this to the angle that is given to us, theta, then we'll say that sin theta would be opposite over hypotenuse, and then cos theta will be adjacent over the hypotenuse, and then tan theta will be adjacent, your tan theta is opposite over it is your opposite over your adjacent. So these are your three ratios and we have them as so. that is just to refresh your mind about the trigonometrical ratios. So let's put it in the context of the force and its horizontal components. Now, if you are given your force and then you are asked that you must determine your horizontal component and your vertical component graphically. Let's say the angle that you are given is this one here, theta. Theta is the angle that you are given. Now, for here we can say, we can bring our VC here, because remember this side is equals to that side. So VC is that one, and then your horizontal component will be that one. So according to what we are given here, if we say we want to solve for VC, remember you are given your resultant, which is the force, and theta, which is the angle. This is what you are given in the triangle. So for now, I want us to consider only triangle number 1. Forget about triangle number 2 for now. We are considering triangle number 1. Now, if we are at this triangle, then you are asked determine or calculate VC, the vertical component, and the horizontal component of the given force. Now, we are going to say, if I have the angle in R, my VC is my opposite side. My HC is my adjacent side, because remember your 90 degree is there. So it means my VC is on the sin. I will use the ratio of sin, because I have resultant and the hypotenuse, and then you have the angle, and you are looking for the opposite. So it means you will have that your VC will be equal to the R. Remember, R is our force that we are given, that we can abbreviate with F. So meaning my VC will be F, which is the hypotenuse, and then it will be multiplied by sin theta. You are doing a cross multiplication here. So the opposite in this case is your VC, and you will calculate it by F equals to force sin theta. Our horizontal component, we have the adjacent side and the angle. So we are calculating the adjacent side, which is our HC. We are given the hypotenuse and the angle, meaning we are going to use cos. So it will be force cos theta. If you are given the angle between the horizontal component and the vertical component, it means you are going to have force. For vertical component, you are going to have force sin theta, and then for horizontal, you are going to have force cos theta. Those are the two formulas that you are going to calculate. Now, let's say they give you angle theta as that one. Now, we are forgetting triangle number 1. and we are focusing on the second triangle. So for now we close this one, and then we are focusing on the second triangle. Okay, now this is your 90 degrees. This is our theta, the angle that we are given. And remember, you have your force or your resultant. We are now bringing our HC this side, because we said we are dealing with triangle number 2. Now this means that HC is the opposite and VC in this case is the adjacent. This is when we are using triangle 1. Now if you are using triangle 2, it means your vertical component will be equals to force cos theta, because now you have the adjacent side on VC, and then your horizontal component will be force sin theta. This is when you are using triangle 2. But if you want to stick, let's say, to only using those two formulas, if you want to keep sin for VC and cos for AC, then if you are given the angle between the vertical and the force, you can calculate your angle between the horizontal and your force, so that you can keep the first formulas. If you want to use a triangle that is down or triangle number 1, it means we have to calculate that angle, and an angle there would be 90 degrees minus the given one. So it means the one angle will be 90 minus the second angle. So whichever you are given, you can calculate the other angle. So this is the two formulas that we use to calculate our AC and our VC. Now let's proceed and do 2 examples before I give you or leave you with an exercise. Okay, example number 2 says calculate the components of each of the forces shown below. I have used the same diagrams or the same forces as in the previous example of the analytical method, of the graphical method, so that we can see if there is similarity or the answers are the same when you have drawn and when you have calculated. Now you will also see that in our answers of the analytical method there will be decimal places, but in the graphical method we are more exact and we give our answers without decimal places. Now let's do the first one. I've written down the formulas already. We just continue with the calculation. So for VC, if we are to indicate it here, meaning VC, our triangle will be there. We are using the one triangle. 90 degrees are here. Okay, so our VC will be, the force is 60 sin 55 degrees, and you do that quickly on your calculator and say 60 sin 55. I got 49.1. Let's leave it to 2 decimal places. So we are going to leave all our answers to 2 decimal places. The first answer is 49.15. 60 cos 55 degrees. This is 34.4 newtons, 1 newton. Then we move on to the second diagram where VC is 53 sin 40 newtons, 40 degrees. So it's 53 this is 34.06. And then our AC will be 53 cos 40 degrees. And that will give us 40.6 newton. So there you have it, easy peasy. You take your formula, you place in your correct values, and you get your answers. Now I'm going to leave you with work to do, and please confirm your answers at the end of the chapter, because the end of the chapter has answers. So please familiarize yourself with the answers to just make sure you have the correct answers. Now you go on page 103 in your textbooks, and then you look at self assessment form. You are going to do from number 1, you are going to do number 2, you are going to do number 3, and number 4. Please, you must read the instructions carefully. That is the exercise that you are going to do. If you have some difficulties with getting the answers that are at the back of the textbook, please leave a comment in the discussion forum or a private message on e-learning. I will attend to it. Thanks for watching and listening. Please keep learning.